The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@yvcc.edu and I will respond as soon as I can. All right, today we are reviewing for the test, which is tomorrow. Yeah, so we won't be having a class meeting tomorrow. You'll just take your test. And we're going to start off. I have a question. This is number 17 from section 8.9. So I'm going to share that. And this is a bit of a tricky one, I will admit. So number 17, it says solve the problem by writing a variation model. The pressure of a certain amount of gas is directly proportional to the temperature. And that word proportional, so instead of saying directly proportional, you could say varies directly. They interchange the word variation and proportionality. But anyway, the pressure of a certain amount of gas is directly proportional to the temperature measured on the Kelvin scale and inversely proportional to the volume. A sample of gas at a pressure of 1 atmosphere occupies a volume of 1 cubic meter at a temperature of 259 degrees Kelvin. When heated, the gas expands to twice its volume, but the pressure remains constant. To what temperature is it heated? Okay, so we've got P is going to be pressure. T is going to be temperature in Kelvin, and V is going to be volume. All right, it says the pressure, so P is directly proportional to the temperature, so we've got P equals K times T, and inversely proportional to the volume over V. So our formula is going to be P equals KT divided by V. So let's take a look at that. All right, so we've got pressure, temp, and Kelvin, volume, P equals KTV, KT divided by V. All right, it says a sample of gas at a pressure of 1 atmosphere, so P equals 1, occupies a volume of 1 cubic meter, so V is 1, at a temperature of 259 degrees Kelvin. So we get 1 equals K times 259 divided by 1. Any questions before I go on? All right, now we're going to use that information to solve for K. So basically this is the same thing as 1 equals 259K. We'll divide both sides by 259 and we get K equals 1 over 259. All right. Then it says, when heated, the gas expands to twice its volume, but the pressure remains constant. Okay, so that means the pressure is still going to be 1. We know that K is 1 over 259. It says the gas expands to twice its volume. So the volume was 1 cubic meter, now it's 2. What is the temperature? So our formula now looks like that. Any questions? Okay, now let's take that and let's simplify it. First of all, let's focus on that whole thing, which in effect is the coefficient of T. All right, if we've got 1 over 259 divided by 2, that's 1 over 259 divided by 2. That's 1 over 259 times the reciprocal of 2, which would be 1/2, which gives us 1 over 518. So that number goes in the place of this whole thing. So now we've got 1 equals 1/5/18 times t, or we could say 1 equals t over 5/18. If we multiply both sides by 5/18, we get that the temperature is 518 degrees Kelvin. So basically, if the pressure stays the same and to double the volume, you also double the temperature, okay? Perhaps something confusing there. It says, but the pressure remains constant, meaning it stays the same as it was before. Any questions about that problem? All right, that was the only request I've got. So do you have any questions that you'd like to look at from section, what is it, 8.9? Anything at all? Keep in mind, there are 3 kinds of variation we talked about. Direct variation, where as one goes up, the other goes up. As one goes down, the other goes down. The variables, that is. There's inverse variation, where when one goes up, the other goes down. When one goes down, the other goes up. And there's joint variation, where you have more than one variable on the right side of the equation. Okay. Any questions about section 8.9's homework? All right. How about questions from the chapter 8 review? Any questions at all? I guess it's going to be a short meeting. All righty. Well, if you don't have any more questions, we'll call it a day. Again, the test is there. You can take it any time, but once you open it, then you have to finish it. The time starts, and there'll be no class meeting tomorrow. Just take your test. I'll be giving an office hour this afternoon if you decide you've got some questions at 1:15. I'll also have an office hour tomorrow at 1:15, though since you'll be taking your test, I doubt that I'll see you then. But if you don't have any other questions, we're done. All righty, I'll stop the recording.